Hello everyone. I will try now to work with another example, but maybe we will do that a little bit faster because we already have a demonstration before. This one is about Boston housing dataset. This dataset is a free dataset which is available. You can search for it online, and if you called if you search for Boston housing dataset, .csv like this, you will find the data. It's available on GitHub. You can download it, all right, as we did last time from here and so on. I already downloaded the data and I would like to upload it. So let me just upload the data set. I'm gonna go here and I have a CSV file, Boston housing. Yes, here it is, Boston housing. I'm gonna upload it here. All right, so I have the file. Of course, this data has many features, but I will try this time to work with two inputs or two features as input and one feature as an output. Okay, so let me first load the data set. I'm going to go here and say define a data frame equal to, I think we now are expert. When I load the data, I say bb read underscore CSV, and then we call the data Boston housing .csv. Of course, you can, if you don't want to miss the spelling, you can go here and say rename, and then copy this, Control C, and then paste it over there. Let's see. Uh, the data is okay. Oh, BD is not there. Now we forgot something which is very important. We should, before that, this step actually to upload the libraries. Remember that? So I have the libraries here. I'm gonna copy and paste the libraries. Here it is. So I'm loading the Panda from the previous notebook, and then the matplotlib. That's very important. I'm gonna upload again scikit-learn, the data set, the model selection. You can keep this every time you work with linear regression. We need to upload the train test library. We need R square. I will tell you about what is R square. It's another evaluation criteria that we can utilize, such as the mean square error and mean absolute error. So if I run this, okay, I'm loading now the functions. Now I already loaded the data. I can say df and see what this data contains. So this data contains all these attributes. Let's make it head just to show 5 records. We said before that you can upload whatever record you want. Now in this case, actually, I would like to use a new command. As I said, I'm trying always to give you some new commands as we go. I would like actually to use middle. This is a maiden value of a house. Of course, the detail is here. I'm gonna keep this. I'm gonna post this on the Google Drive, which is this target, which is the maiden value of owner-occupied houses, and I'm gonna consider the input as RM, which is the average number of rooms, and also I'm gonna consider the I think the L state. Where is the L state? Yes, this one. Percentage of lower status of population. These are the values which I'm gonna utilize as input. But as you can see here, all these are in small labels. So I would like to here to do something. We call it rename some variables and use it for my new data frame. Okay, how I'm gonna do that? I will define a new data frame. I'm calling it df and dot rename. I'm gonna rename some attributes, which is column. Okay, I'm gonna rename the column. How we do that? We open curly brackets, and the column that I want to change is MEDV, which is a maiden value of the house. I'm gonna call it maiden. It's MEDV, and I'm gonna call it target. Okay, colons. I'm gonna call it target like this. And also I want to change the RM. Sorry, I have to make it small. Yes, the RM, because it's here. It's RM here, and I'm gonna call it to column. I'm gonna call it RM capital and another comma, and then I'm gonna look at the L state, LSTAT, and I'm gonna call it L state like this. Okay, and so RM is there. I'm not missing anything. Okay, if I run, I think what I did is I did not need to write df one more time. If I want to write df.head here, I can do that for this df. Yeah, that's what I need to do. So I'm selecting these three targets only, not the original df. Now, before we continue here, we need to show some characteristics. I really want to see the relationship here between these attributes, the inputs and the outputs. So if I would like to do that, I can draw the relationship again between, I'm gonna get this lot dot figure, and then I'm gonna show fig size equals, and I'm gonna use 10 and 5, and then I'm gonna call features. I'm gonna call the features, the inputs here in my case is df, and then I'm gonna use, actually I should have two inputs here. The let me just click on this one and get these two only, right, as input features, and then I'm gonna get target. And sorry, I'm trying to work fast to make this a short video here. And this is target equals to df, and then target. Okay, let me see. Yeah, we have an extra brackets here. Yeah, so this one is working. Now what I need to do is I need to create a plot. So I would say plot dot figure. I can we already did a plot size, so if I would like to make it as a subplot, I can do that. If I would like to go ahead and say subplot, and then say 1 2 1, and then say plot. I would like to plot the I would like to plot the scatter, and I can draw the df along with L state, right, correct, and the df and the target, because the target already is defined here. And then the other subplot, I can say plot dot subplot 1 2 and 2. I say plot here, I'm gonna use the RM, and I'm gonna say plot dot show. Okay, let's see what's gonna happen here. Here we go. So this shows the relationship between the variable, the target, and the target and the RM. So I can add here plot dot x label. Okay, this will be LSTAT and y label dot y label. I'm drawing the target, which is in this case the target or the median price, right? Median price of the houses. Just for simplicity reason, I'm gonna do this. Let me reduce the size here and make this, for example, so that we can see it 6 and 4, for example, and then see what's gonna happen here. Label, okay. I'm glad that we are making mistakes, so we learn from our mistakes one after the other. Sometimes we go fast, so we learn now. Now this is a relationship. As you can see, the relationship here between L state and the target is negative, and the relation between, this should be, by the way, RM, not RM, and this is positive, right? And this is, by the way, realize that since the distance is small here, I think it's better now to increase this distance. Let's make it 8, so that will make the figure better. Yeah, I'm glad that we have some of these mistakes, because it helps us to learn more about what's going on. Okay, now we were able to plot a figure. We defined that, well, I defined this as a feature, so I can use it later on while I'm doing the train and test split. Okay, and here I'm drawing this values. All right, that shows us the relationship between this. Now the next step is going to be, we already decided upon this. I think we already decided upon this, so let me move this down. Okay, and we already decided. Now let's split the data. I'm going to add a code here. Let's move it down. Let's move it down. Here we go. So I'm going to call X train and X test, Y train, comma, Y test, and then after that simple command train underscore test underscore split, and again we're gonna feed the features. In this case the features are actually the two variables L stat and RM, and the target, which is in this case the median average price, and then we say test size. We make the test size equal 0.2, and of course we need to define the random state. Random state equals 23, as we did last time. Okay, now if we run this, we already split the data. Now in order to import the model, importing the model, we're going to say model equals linear regression capital. Okay, this is a model. Let's run it. Okay, we have a problem. Oh, linear regression is not defined, so in this case we need to import the library for linear regression. As I mentioned, in the future we can import everything from the beginning. I'm gonna call from scikit-learn import from scikit-learn dot. Remember last time we call it linear model. Okay, here we go, and then import, and then we import the linear regression. This one, here we go, and then we run this quickly like this, so we got the linear regression model. Okay. So now we imported the library and we initialize the model. Actually I should split this. This is importing the library, and it should be initializing the model here. Okay, I'm just splitting it, and then after that we need to fit the model again with the train and test the data. Okay, so that's what we're gonna do. Fit the model. I'm gonna create a code. I will just do it this time based on the test data. Okay, for simplicity, we already did the post, or you can copy it from before, because it's gonna be the same commands that we did before, right? Model fit, and then you say X train and Y train if you would like to do it on the training data. Of course, we need to fit on the training data, and then we say Y predict. I'm gonna call it equal to model dot predict. Okay, and I'm gonna test the model on the test data X test. Okay, which is a 20%. If I do that, that will create the Y predict, Now the next case is I would like to draw the relationship between the predict, the y predict, and the y test. Okay, let me just grab uh, the I don't think we need, just maybe you can get this plot figure size. We can come here and then insert plot figure size, and then I'm gonna plot dot scatter. I'm gonna plot the y test and y test predict. Okay, we called it y test predict, right? Oh, y predict. Okay, only we called it y predict only. Y predict, and we can, of course, we can add the plot dot x label. I like to call it actual y, and plot dot y label estimated, or you can call it predicted y. Okay, and then plot dot show. Here we go. All right, so this is the we can, as I mentioned, we can reduce the size. Maybe it will be clear that this is the relationship. One more thing after we got this model, actually we can do is we can get the intercept will equal to model dot intercept, and we can get also the value of the other the parameters, or if you want to call it the parameter, call it coefficient. It will be model dot coefficient. Okay, and then we can after we get that, we can print the intercept. Okay, this is the intercept, and we can print the coefficient. In this case, we're gonna have, how many coefficient are we expecting? Two, correct? So we have two coefficient, one for the L state and one for the Rn. Okay, so we can get the model now, and this is a visualization. We would like to evaluate the model. So we talked last time about the mean square error and mean absolute error, and here we talk about the R square. So R square basically is the ratio between the, as you can see, the actual minus the estimated square, the sum of the actual minus estimated square, divided by the sum of the actual signal minus the mean of that signal. Okay, minus the mean of that signal. And then this is 1 minus. So this is 1 minus this ratio. So, for example, if this ratio is 0, then R square will be 1. Okay, and when this will become 0, if you look here carefully, if yi minus yi hat, which is the estimated response or predicted response, is very close, is very small, then this number will be very high. That's the idea. All right, so let's calculate the mean square error and mean absolute error. Let me I will grab this from the code that we did before. Here we go. So this is from our code before. So this is the mean square error y test minus y predict, and then we calculate the mean square error. Mean absolute error is y test minus y and y predict again, and then we calculate the R square scored. This is the library that we imported at the beginning of this notebook, and then we feed the test and predict again. If we run this, that will give us the mean square error was about 30, mean absolute error 4.3, and as you can see, this R square is 0.64. It's like 64%, so it's not that high. Okay, now if I want to use this model for prediction, so I'm giving you some information here about L state and number of rooms. Okay, L state and number of rooms. So in order to do the prediction, I will do the following. I will try to create a data frame which has these new values. So I'm going to call new houses data equal, and then I'm going to create a data frame like this way. I'm going to call LSTAT, which is the first input, colon, and then I have what values? I have 5, I have 4, comma, 4, and I have 15.0, and then comma, and then I'm defining the RM, okay, colon, and then I have the values are 7, 6, 8, 7, comma 6, comma 8. Now this is a data that I would like to show or predict. Now I'm gonna call new house data. I'm gonna call this data frame, okay, and it will equal bd dot data frame, and then new houses data, okay, right? So now I created a new data frame, and this is gonna be, I would like to see how it looks like. Here it is. So I'm preparing the data for testing or for predicting. All right, that's gonna be the step. Now the next step is I need to feed this data for my model. So I'm gonna say predicted houses prices, and I'm gonna use the model dot predict, and I'm gonna feed what? I'm gonna feed the new houses data frame, this one, Control C, Control V. I'm feeding it here, and of course I can get this one here and paste it here. Here we go. This is the new house prices. If you want to make it looks nicer, you can add a new column to the predicted pricing to this data frame. You know this one, you can add a new this data frame. You can add a new column which shows the new prices. So I can call this new houses prices, and then I can say predicted prices. I'm just trying to make it looks nicer, and then I have what? I have the predicted houses prices, this one, this is equal, so I'm feeding this value here, and then I would like to see again the new houses here one more time after I added the new column, and here we go. So now I have the input values that I need to test, and then the predicted prices that I have. I think this will conclude this notebook, and I hope it is useful. Now we tried a practical application on Boston houses prices, and so as a summary, these are the data. I think it's a good idea if you're gonna use the linear regression from the beginning. It might be a good idea if you just import this file, import this library at the beginning. I think so. It's a good idea to import it here, and that's what we're gonna do in the future. So you can put it here. You don't have to import it inside it. And of course, you can execute this one more time to make sure that everything is running. We just knew about a new command called rename, so we can say data frame dot rename, and then you selected a column that you want to rename, and so on. And here this is the data that I want to utilize. So of course df here didn't change. The only thing that happened here is I am showing the input and output. By the way, df didn't change here. Here I selected the two columns, L state and room size or room number, and then I call this as target, and then I continue. I'm showing the relationship that would help us to see the output. So L state has a negative relationship. Let's look at the value. Here it is. So L state has a negative relationship. This means that it has a negative coefficient, and now this is a positive relationship with the room number. Okay, and I show the relationship. By the way, we could do something, but I really it's not gonna be accurate, but maybe if you like, look here at this. This is from 50 or 50. I think maybe if sometimes we can do something like this if you like. If you like, it's not a must. I commented this before. So I'm trying to draw a line like this between the here line, like as a line fitting, but it's not really. I mean, somehow this is like a line fitting 50 times 50, but it's not really the correct line. But I'm just showing the relationship, because if you change this, it might be different. If you change the dimension here, for example, it might be a little bit uh, different. Yeah, but still, yeah, it's a good. Control Z. But just I mean, for simplicity reason, of course you can plot the straight line that you created from here with the data set if you like. Okay, now let me conclude this, and thank you so much. Bye bye.